Let's start by understanding what Huffman coding actually is. Huffman coding is a popular algorithm used for lossless data compression. It was developed by David A. Huffman in 1952 and is widely used in various applications, from file compression tools to image formats like JPEG. Main idea behind Huffman coding is to assign shorter codes to more frequent symbols and longer codes to less frequent ones, making the overall data size smaller without losing any information. This clever approach helps save storage space and speeds up data transmission. Now, let's see how this algorithm works in practice. Today's digital world, we deal with massive amounts of data every day. Whether it's sending images, videos, or documents, efficient data compression is crucial. Without compression, files would take up much more space and require longer to transfer over networks. Huffman coding is one of the key techniques that makes modern data handling practical and efficient. By reducing file sizes, it helps save bandwidth, storage, and even costs. Next, let's look at the basic principles that make Huffman coding so effective. Core principle of Huffman coding is simple. Symbols that appear more frequently in the data are assigned shorter binary codes, while less frequent symbols get longer codes. This way, the total number of bits needed to represent the data is minimized. Imagine you have a text where the letter E appears much more often than Z. Huffman coding would give E a shorter code, saving space overall. This principle is what makes Huffman coding so efficient for compressing different types of data. Implement Huffman coding, we first need to build a Huffman tree. This tree is a special type of binary tree where each leaf node represents a symbol from the data, and the path from the root to the leaf determines the symbol's code. The process starts by counting the frequency of each symbol. Then we repeatedly combine the two least frequent symbols into a new node, building up the tree until only one node remains. This structure ensures that the most common symbols are closest to the root, resulting in shorter codes. Once the Huffman tree is built, it's time to assign binary codes to each symbol. Starting from the root, we assign a 0 for every left branch and a 1 for every right branch as we move down the tree. The code for each symbol is simply the sequence of zeros and ones you encounter on the path from the root to that symbol's leaf node. This method guarantees that no code is a prefix of another, making the encoding uniquely decodable and efficient. The codes assigned, we can now encode the original data. Each symbol in the data is replaced by its corresponding Huffman code, resulting in a compressed sequence of bits. This new bitstream is usually much shorter than the original, especially when the data has symbols with very different frequencies. The encoded data, along with the Huffman tree or code table, is then stored or transmitted. This step is where the actual compression happens, making files smaller and easier to manage. Coding Huffman encoded data is straightforward. Using the same Huffman tree or code table, we read the compressed bitstream and traverse the tree according to each bit, left for 0, right for 1. When we reach a leaf node, we found a symbol, and we start again from the root for the next set of bits. This process continues until all the data is decoded, perfectly reconstructing the original information without any loss. Huffman coding isn't just a theoretical concept, it's used in many real-world applications. For example, it's a core part of file compression formats like ZIP and GZIP, and it's also used in image formats such as JPEG. Even some communication protocols rely on Huffman coding to reduce the amount of data sent over networks. Its efficiency and simplicity make it a go-to solution for lossless data compression in both software and hardware systems. Wrap up: Huffman coding is a powerful and efficient method for compressing data without losing any information. By assigning shorter codes to frequent symbols and longer codes to rare ones, it minimizes the total size of the data. The process involves building a binary tree, assigning codes, encoding, and decoding. Its practical applications are all around us, making our digital lives more efficient. Understanding Huffman coding gives us insight into how data compression works behind the scenes.